Hello and welcome back to my experiments in procedural generation. And this time I'm continuing from the last time where I got the so-called convolution. So let me make this clear for once. The algorithm, what I call convolution, is not an actual convolution. It just reminds me of what convolution does. I won't go into detail because that's boring as no one wants to hear it, and the people who want to hear it already know how it works actually, so let's just get on with this. So last time I was fiddling around with the DLA system, diffusion limited aggregation, and that did not work out too well. So I decided to keep on going and try to get the space colonization algorithm working. So I did that, and it was kind of hard. But then again, I learned a lot of new things about vectors actually. But yeah, anyway, so here we have a screen with these white dots, which are the baits as before. And I'm now going to shoot one space colonization thingy at them, and we'll see what happens. So it should come from the top, I think. Yes, there it is. And there is, every time it hits one, there is like 50, I think it's oh, did I take it off? Well, it generates two new like segments that start growing, but I think it's sometimes there's small chance that it won't generate the second one, so it kind of makes it a little bit more randomized. So let's keep going. Also, there are other rules applied which were not in the original one. For example, this one, when it goes beyond the screen, it kills itself. Also, it can also now see these baits that are in this frustrum in like a what it has to see it like it. I can't remember. It is very white, the frustrum it has, so it's able to see many baits, but it can't see anything behind it. For example, this thing here that's moving downwards, it could not see these two baits if they existed. So it won't try even to like go there. I think the frustrum is like 90 degrees, or was it even 180? So it is a lot, but yeah. So let's keep going. Also, this now has a rudimentary collision detection. So if any of these collides with well, let's say branch of its own structure, it should kill itself, but there is some sort of bug there also. I think I know what it is. It sometimes does not work, and I think I know why, but let's not go there. So let's just keep regenerating. Actually, there we are now going to see a collision. Actually, they already happened collision, so hopefully most of these will die. And yeah, looks like it worked this time, but I would still like to have some sort of better method to like fix this. It's now, yeah, it makes these too busy segments quite often. Also, I've noticed that the way I distribute these baits is not ideal. It clumps them too much, so I should probably look into something called Poisson disk sampling. I haven't yet seen how it works or how hard it is to implement, but I think that may be what could help me with this. because now there could be like a place where there's, well, this is a good example here. There are 5 points very close to each other. I mean, I could make a check to like go through all of these points and check every other point. If it's too close, kill the point in question. But that again could eat some processing time, and I'm kind of not. There we can see the collision. By the way, it did not work. I think it went straight through it. Yeah, so that didn't work. Okay, and the last one. Okay, so it generated this quite huge structure. This is something I actually want, but there's still room for like lots of improvements. Like the collision thing, it just does not work yet. Also, it's too busy at places. I'm not liking that, but that could be actually because of these pages are not like distributed properly. So let's actually start applying the so-called convolutional thing and see what we get. Okay, there's something very odd there. Yeah, I know. I have not yet automated this thing because I kind of like it this way, so I can see what happens. How does the algorithm work step by step? So let's keep pressing until I think it's done now. Okay, let's take this to Blender. Let's reload this. Where is the... There we go. So this is what came out of there. Now, these huge cliffs are kind of problem. I mean, they add some nice variety to the terrain, but that's not what we want. So I made a simple algorithm to fix that. And it's called, well, I don't know if the algorithm itself has any proper name, but the thing it simulates is thermal erosion. So I can just start pressing, I think the key was, yeah. So if you look at this hard edge here, we can see that the if the well, actually we have this thing here, so why not use that? So this works like if there's too much of slope, it will take stuff from the top and deposit it in the bottom, and I think it tries to aim at something like, I haven't actually calculated it, but I think it's somewhere between 45 degrees angle at where it rests. Actually, that's also called, it had a name. What was it? Was it angle of repose? Google it. But all soil has this K factor or whatever it was called, but I think it was angle of repose. So basically all of these terrains, angle of repose is 45 degrees. But yeah, let's actually, if I now press C to export and reload this, we should see this edge collapsing a little bit. Yeah, as you can see, it worked. So let's keep going to make that even smoother. Now this is problem for the in the end, because what I'm now doing is authorized editing. So I'm looking at this shape and pressing key until I think it's fine. Now that kind of system won't work for procedural stuff, so I have to like guesstimate the amount of loop, this thermal aeration loops I have to apply. So let's just keep pressing for a few more times. There, and export, and now we should have pretty nice, well, nice in, yeah, pretty smooth at least. So yeah, now it's smoothed out. And we have much more pleasant terrain. Yeah, so so I got this thing work this well, and I was kind of pleased already with this, and there is many things that could be improved. The things I mentioned before, but even with this thermal erosion thing, it's just a little bit like what I like to call duct tape solution. Yes, I know it's duck as in the bird, but yeah. So it's like a fix that really does not fix the actual problem. It just paints over it, if you know what I mean. So yeah, there's many things I would like to improve. Also the DLA algorithm that makes these valleys. No, not DLA, the space colonization thing. It's actually pretty okay, but there's so many things that it still needs some work and love to make it better. But I started having problems with this Blender side because this is kind of hard to read, this gray mass. So let's check out the shaders, and I made this. Actually, I stole it from somewhere, basically. There was a, well, it actually might have been Blender's own manual where I looked at. But what this does is, it simply takes texture coordinate from the object and maps it to, well, actually, yeah, vector, and then I just take the z value, which is in Blender like a height of the, and I use that to map with color ramp a specific color to the pixel in question, and I apply it to the actual shader diffusion color and output it, and the result is anyway. If I now change to the rendered version, we get this out of the map, and this is pretty much like a much more well, it's clearer. I can see these values better because everything that is low is like colored green, and the higher it goes, it eventually goes to white, like these peaks here are white. Yeah, so that was something outside of the actual procedure generation. It's just shader, but in a way actually it is one aspect of this, but I'm not going to use this, I think, for anything really. It's just for me to see what's the generation doing better. So yeah, yeah, there's not much else to say. Let's actually do one more generation just to see the variation. Oh yeah, this is one interesting thing. I'm not sure why this happens. Sometimes the new branch fails instantly, and I think it's something to do with the frustum thing. But then again, I think these would be close enough and in its view, but it's hard to say. I haven't made any debugging yet into this, because I don't really care that it generates so many of these. It usually doesn't bother me. But let's see how this works. Okay, that is overlapping, I think. I think this won't be a... Yeah, well... Hard to say. I also started thinking about an idea where I might be like generating segment just randomly, very random, but it could break these long stretches of nothingness. And probably the generated things would be short-lived because in general they don't have much to look at, but occasionally they could spot something. So yeah. And we have this. There was quite a huge chunk of unused ground here, so probably this won't be too nice. So maybe I should add something like shift button, shift modifier for this button. So if I press shift and this, it would run 10 convolutions once. Yeah, actually that's good idea. Yeah, this will be a huge mountain, I think. And it's murdering my finger. Yeah, I need to make the automation for this thing. I really should, but it's not that big of a priority. Okay, and let's now apply the thermal erosion for a few loops. That looks fine, and let's export it. And let's see, what do we have? Bum. Yeah, that's pretty nice looking river valley there. Yeah, actually, one other thing I noticed that is if I enable this, I can see the cells, but now I'm not actually sure. There might be some aliasing going on because the way this thing, like a height map comes to the Blender from processing is just by screen capture, so it's not in its native resolution, let's say. And this grid is 300 by 300, and the pixel map is actually 900 by 900. So there might be some blurriness coming if it's downscaling it. I'm not sure. It's hard to say without making actual tests of it, but yeah. So this actually allows me to check what the possible geometry might, and I must stress this, might look at if I look at it closer with this resolution. Now, also this made me think about what I'm actually looking at here. What is the size of this terrain? And I had not really thought about it before too much, but now that I look at it, it seems like it could be like some few kilometers squared perhaps. Because yeah, this level of details looks like to be in that scale, I think. Actually, can we somehow measure a point? I was thinking about maybe I could measure like how tall is this hill here and how tall it looks to my eyes. And yeah, that's actually kind of painful to look at this moment. So yeah, also it probably depends quite a lot where you are from because this actually looks kind of alpine scenery or something very mountainous, but it could also be that the colors are tricking. Maybe this hill is only like 100 meters or so, and this is a small creek, which would make this just few hundred meters. Although in few hundred meters, shapes like these are not that common, I think. Well, I would have to check geology books on that, but actually, geology is quite what do you call it? Quite fractal. I mean, same shapes scale down and up, especially in rivers and flowing water. I mean, shapes caused by flowing water. But yeah, to my eyes, this looks like a few kilometers in quite rough terrain. Looks like a sort of like a foothills of a big mountain or something, and that's quite fine for me. And is that? I wonder if that's like a. Is that like a? I don't think that's even like a one of these branches. I think that's caused by the convolution. Actually, we can check it from here. Oh, this is hard to read. I think it's this one, maybe. Yeah, probably. So that's not caused by the generation. That, well, I mean the this Greek generator does not do that, but it does make all of these. Also, one key aspect of this space colonization thing is that it tries to make sure that as the particle wanders along, it constantly adds to its own height, so it keeps growing up, and that should enforce the idea that these rivers flow down. Like as you can see, this where the particle started its travel, it's almost dark, like a very dark green. And if you actually look at this this way, oh yeah, here we can see the color band also. That's the lowest point also. So it kept moving, and all the time moving up also in the Blender's z-axis. Well, not Blender's, but its own world z. I mean height. It doesn't have the z actually, but it could be considered as one. So yeah, that should enforce the way that these always run downhill, and that's quite important for me for what I'm going to do next, hopefully, which is simulate some sort of fluid movement. I'm not. It's I won't even try simulating fluids on this because I'm too crappy of programmer for that, but I have some other ideas I want to use these for, like make inverted space colonization kind of thing, but that's a thing for some other time. But yeah, that's what happens. Let's check quickly one more generation, just to admire our creation. Yeah, of course it takes a while to me keep pressing buttons, but it's also somehow like hypnotic to watch this unravel this vines of rivers or whatever. Also, I actually been thinking about this this convolution thing. I had another kind of idea how to make this, and it probably causes a lot more. Well, let's say that it's dependent on the thermal erosion thing, because without it, it will cause problems, I think. So it's bad in that way, because this algorithm doesn't really make that. I mean, it sort of compounds the problem into these huge ridges, but another way to do this probably causes a lot of smaller ridges. But yeah, it's this or that. Hard to say which works better, but okay. And there we go. Let's check out in Blender. No. This. And there we have it. Whole new bunch of things. Actually, that's kind of weird. How did that happen? I mean, it seems it's like going in the wrong direction. This one. I think there was like a... It must have been this which split at here, or here somewhere, and the other one just happened to have probably collided already with this and split again, which sent it. Oh yeah, all of these splits are take 45 bit. I mean angle between 45 and I think it's 150. No, 115 degrees to the left or right of their current heading. So there we can see that's probably 45. That's pretty much 90. That's probably over. Actually, I think it might be 135 or something. But point is that I can control how, like, what's the angle the new branch goes. And I've been trying out different ones, and this seems to work best. One interesting one is that if I limit it to be quite narrow, it generates sort of cleaner things, but it collides a lot more, and I don't like that. So it's always the case of this or that problem constantly. But yeah, I think this is getting quite good. It's of course needs still needs huge amounts of work. That's weird, so weird looking thing this. But that's the beauty of this thing. I mean, even I keep wondering, how did this happen? Or that looks interesting. Okay, oh, actually, this shows one problem of the thermal erosion. Now, here we have a creek, this valley, and the thermal erosion is cutting into it. And actually, if I probably keep pressing a few times more here, it will collapse completely into the... I added some randomization to this thermal erosion also, so it should like mess things more a little bit. Let's see what happened. Oh, so it's at rest already. That's interesting. Oh wait, did I save this? Let's try again. Yeah, it's still collapsing, but looks like this is already at rest pose. So it's... But yeah, there you can see the creek comes here, and at here it cuts down. And once I start the fluid simulation thingy, perhaps this will be a problem. Well, it depends how you look at it. For an erosion, this would be actually quite interesting, but yeah, I'm not sure if I want this. I could protect these so that if they... well... and that would cause other problems. So yeah, it's this or that. But yeah, this is quite interesting. Yeah, well, that's enough for this time. If you are interested in more into this, just post a comment, and I'll be checking them out if anyone has any questions. basically. So yeah, let's see where this takes us. For the next few things, what I have planned for next time is that I was thinking about combining these two again, because I was thinking about the diffusion limited aggregation, and I think I made the fundamental error in that I operated at pixel level, like 1 cell level, but maybe I should have actually like used this sort of similar thing that the space colonization use, like these X and Y sized particles that collide with each other, and every time they collide they grow a slightly smaller but also lift themselves a little bit up, so that would allow me to control this thing way better. But the problem with that is that, as before noticed, the diffusion limited algorithm is quite slow, at least when I do it. Maybe someone who's better at this stuff can make it run in light speed, but when I do it, it's kind of slow, and that's one of the key things. I want to keep this very fast, and I think this algorithm, as it's now, if I eliminate the human factor, which is me pressing button to generate each step, it probably runs in mere seconds, or probably even less time. I'm not sure. I haven't tested and probably won't too soon, because I just want to develop it at this moment before I take it into uni to do stuff in there, maybe. But yeah, that's what will probably I might try next. I mean, and also I'm starting to already think about the fluid things, but those I might actually. Well, I'm not sure about those. I would have to test them somewhere, or maybe even see if I could export this to some system that already has something like that, and see if the idea even works. Because the fluid simulations are pain in the ass, really. But yeah, this is kind of interesting thing to play with at the moment. So yeah, well, I think that's enough for now. So let's see what happens.